So hello guys, welcome back to the channel, and today we are going to solve this question, trapping rainwater. So in this question we are giving a height of the array, and we are finding in between the height of the array how much water can be trapped. So each bar representing the height of the uh, array, like in this example we can say that height is given like this. So it's 0, then 1 height, then 0 height, then 2 height, then 1 height, then 0 height, then 1 height, 3 height, then 2 height, then 1 height, then 2 height, then 1 height. So this is the height. Now imagine there are some clouds and there rain happens, so rain will be up like this and rain will be stored. So here rain can be stored because in the left of this there is nothing, so water should come and go. Here also can stop because there is nothing in the left of it, but here can stop because there is in the right and left there are some portions, so rain can be trapped here. Here not trapped, here trapped. Here rain can be trapped, here rain can be trapped. Then here not trapped, here not trapped because there is no support on the right. Then rain get trapped here and here not. So just far from this. So rain can be trapped in between them. So we have to just return that how much rain can be trapped. So 1, 2, 3, 4, 5, 6. Our answer is 6. 7. This is a question. Our answer is 9. So how we approach this question? If it comes in interview, then how we approach this question? So I will teach you two methods. Methods to solve this question. So method number 1. So what we're gonna do in the method number 1 is, like, if we find what we can do, like if this is the height of the array, and like if we find what is the because one thing we observe that rain can be trapped when there is like same height, or one side height greater or one side height lesser, then rain can be trapped. Like in this case, if they will be same size, then rain can be trapped. If the height difference, then rain can be trapped. But if there is nothing in the left of it, there is nothing left or right of it, then rain can't be trapped. Because like if same case happen and same this height and this height and this height, it's continue like everyone is too high, then nothing can be trapped. There can be height difference, na? So that rain can be trapped. Yeah, this thing we observe. Now again, another thing is that we can say that for this rain can be trapped only if there is some greater value on the right. So if there is greater value on the right, then how much rain can be trapped in this? So there is nothing in the left, so nothing can trap. There is in the left, so or there is greater value in the right, so how much water can be trapped? So there is 1 minus, there gets 0, so 1 minus 0 difference is 1, so 1 can trap. Like suppose here is 0 and here is 1, so 1 minus here is suppose 2 and here is 0, so 2 minus 0, here 2, here 2 minus 1, 1. So difference between the heights, like its size is 2, its size is 0, so difference between these two. Its size is 1, its size is 2, so difference between these two. But the condition can be satisfied that there in the right there is greater value, or for this there is left is the greater value or the same value, then it can be trapped. So we can say that if we find the greater value on the left side, like whose value is greater, go to right, and whose value is greater, go to left. So like if we find a vector array which will store all the greater value on this, and a left array which will store all the greater value in this, then we can say that the minimum height, either this can be minimum or either this can be minimum, so minimum difference between these two minus the height of the array is our answer. Like I'm just make some left array and right array. So for the left, for right, so we are going on the right side and we are checking what is max. So here 0 is max, so nothing can be changed, so 0 is max. So just make like this, just get more real. So 0, now max is 1, now max is 1, now we find a greater value, so now max is 2, now max is 2, now max is 2, now max is 2. So till this one max is 2, now max is 3, now 3, again 3, now again 3, now again 3, now again 3. So we go till left to right and find what is the maximum values. Okay, now go till right to left and find the max values. Just see. Okay, let's go. So here is max is 1, max is 1, now max is 2, now again max is what, now again max is 2, here max is 1, then max is 2, for that max is also 2, for that max is 2, is 2, for this max is 3, and there is no greater element, so also 3. So for this 3 and 1, 2, 3, 4, 7. So 1, 3, 4, 5, 6, 7. So this is the array form. This is opposite to this. Okay. Now ARR value is this. Now the check. So here, what is the minimum between these two? 3. And what is the minimum between these two? 0. And what is the height of the array? 0. So difference between these two is 0. So here nothing can be trapped. Now here, what is minimum between these two? 1. And the height is 1. So nothing can be trapped. Okay, now here, what is minimum between these two? 1. So 1 is minimum because this is minimum. This is the minimum value. Either this can be minimum, either this can be minimum. So this is the minimum value. Now what is the value? 0. So 1 can be trapped. True, 1 value can be trapped. Now go to next one. And what is minimum? 2 is minimum. Now 2 is minimum. And what is the array value? 2. So nothing can be trapped. Here 1. Here 2 is minimum. But the array value is 1. So 1 can be trapped. Here 2 is minimum. So 2 can be trapped. Here 2 is minimum. So 1 can be trapped. Here 3. And 3. Nothing can be trapped. Here 2. But minimum is 2. Where either this can be minimum, either this can be minimum. So this will just take care of this. So either in this case, left array will take care handle of this. In this case, right array will handle of this. Here minimum is 2, so nothing can be trapped. Here minimum is 1, but minimum is 2. 2 minus 1. 1 can be trapped, nothing can be trapped, nothing can be trapped for the last. So that's how the algorithm works. So just makes 2 vectors. One is left. You can say one is left vector. One is right. And for each vector, what I am doing is I'm just finding the max value and storing it. This is for left or right. So for int I equal to 0, I less than let's say int n equal to height dot size. So okay, and I less than n and I plus plus. And I'm saying I'm making maximum. So int maximum equal to let's say ARR 0 is maximum, or yeah. So initially we can say that first value is maximum. First value is maximum. Now if we find any maximum value, so maximum is nothing but max of maxi comma ARRI. So maximum. So if we find any value greater than maxi, then we store it in the maxi, and we can say that left of I is nothing but maxi. So this will store all the maximum value. So this is now you can say that right maxi equal to ARR minus 1. Right maxi value is this. So that's left. It is left maxi. Good name. Okay. Now we get for int I equal to n minus 1. I greater than equal to 0. I minus minus. If any value is maximum, then ARRI, then storing this. So R maxi, comma ARRI. We say that right I equal to R maxi. Okay. So we have made 2 vectors and store all the values. Now what we're gonna do is we are saying int answer equal to 0. So answer equal to 0 and just iterate all the values. So I equal to 0. Then I plus plus. And what we're gonna say that answer plus equal to, so answer value is answer plus first find minimum of either of left eye or either of right eye. What is the minimum value here? And just subtract ARRI from it. Just return answer. As simple as that. Let's run this. Okay, so height. Okay, so replace error with height. So okay, so it's saying reference building to the control. Okay, so the problem is that we are left eye and right eye. We are using left of 0 equal to something, but left of 0 is not initialized. What was the value in the left of 0? So we have to initialize how the value is size 0. Now it's will run it fine. Okay, and so and so yeah, it's expected, accepted. So the code is accepted now. So hope this method is clear to you. Now solve this question using another method. Method 2. So in this method, what we're gonna do is instead of using vectors to store the values maximum minimum, what I will gonna say is just make two pointers to find the max and min in the left and right instead of vector. So saying left max equal to 0, left max, what is left max? ARR 0, right max is ARR 1. Left max is this value and right max is this value. This is correct. Also I'm saying L equal to 0, R equal to n minus 1, and while L less than R until they didn't meet. So we move through the all the values until they don't meet L and R, and saying how can we ensure that there is water trapped into, because if we use this, then how we can ensure that there is something on the right that is greater than this. So for that I am saying if ARR of L, if ARR of L is lesser than or equal to ARR of R. If that happens, then this will ensure that there is some value which is equal to or greater than right, so water can be trapped. Otherwise, all water will fall down. So this will ensure that there is value on the right that is greater. Now, if there is some value in the right, then we don't have to take care of the elements now. Just check for each what is left. So if ARR of L is greater than let's say that left max. So if there is any value which is greater than maximum value, because we have to find the maximum value here, then we can say that left max equal to ARR. Otherwise, if you didn't find any value, then just subtract the maximum value from ARR. So let's make the answer saying answer equal to answer plus left max minus ARR. Just move L. For all of this, just move L forward. Move L forward. Else, what can happen if ARR is lesser, ARR is greater? If ARR L is greater, ARR lesser, then for the right, we can say that if ARR R, if there any values is greater than right max, then what we're gonna do is subtract the value of right max. So right max equal to ARR. As if you don't find anyone, then subtract the answer. So answer equal to answer plus max minus ARR. you have to just return the answer. So is height. So this will appear with height. Now this and is not declared. Just declare and R. Okay. Yeah. Let's run this and submit this. So yeah. So this is the problem. So what we did is we just make two pointers. One is here, and when we iterate, we find out what is the maximum between these two. If this is maximum, then the difference between this is the answer. If and what's the condition? If anyone in the right is greater, then you have to do it. Because for that you just do it. But if anyone, but if no one is in the right, which is greater than this, then there is then you can't track the water between these two blocks. So just, first we ensure that there is always some right, yeah, or left which is greater than this. Then we check if it's greater than this, then update this. Otherwise, water can be tapped and this and this. So, so yeah, this is for the video. Thanks for watching.